So next up, now that you know what vectors are, the next thing we need to be able to do with them is how to add them to each other, how to add two vectors together. And this sounds simple, but it's actually not so simple. And is going to be something that we'll be doing a lot in problems all throughout the semester. So it's something that you really need to get accustomed to thinking about to really wrap your head around this class in general. So let's say you have two vectors and you want to add them to each other. How do you do it? Well, there's two methods. Just as there's two representations to how to represent a vector, there's two ways to add vectors. So they can be added in either the magnitude, direction representation, or in the component representation. And the procedure is different depending on how you want to do it. So kind of spoiler for this section is it's going to turn out that adding vectors in the component representation is, practically speaking, much easier. So 99% of the time, we're going to add vectors using the component representation, but it is useful first to go over how you would add them in the magnitude and direction representation, because this is actually, turns out to be very useful conceptually for picturing how you add two vectors to each other. Although practically speaking, it's not really the best technique when it comes to calculating things. So first, how to do it in magnitude direction representation. So what you basically do is, let's say we're trying to do, A plus B. We're trying to add two vectors, A plus B. Okay, let me make that explicit. So let's say we're trying to add A plus B, and we'll call the answer C. So let's say we add two vectors, A plus B, and it gives you C. Here's the basic procedure. Starting from the origin, draw vector A in the usual way. So vector A is an arrow, which points outward from the origin. It gets you to some other location. Now, here's the trick. Starting from the end of vector A, draw vector B. Not starting from the origin, but starting from the end of vector A, you draw vector B coming out of the end of A. So then it turns out vector C will be the vector that goes straight from the origin to the end of B in one step. So in other words, vector A, vector B, and vector C will form a triangle. With vector A, then B, and C will be the third side that gets you directly from the origin to the end of B. Let me show, this might sound a little bit abstract. Let me show it to you. I'm going to flip over to my lecture notes so that I have some pre-made vectors. So let's say these are my vector A and my vector B that I want to work with. Okay, so what would adding them look like? Now, again, as I was mentioning, quantitatively adding these two vectors in this method is going to be quite annoying because it's going to be some horrible geometry problem. But conceptually, it's very nice because it's not even obvious right away which direction A plus B is going to be pointing in, which direction even is vector C going to be pointing in. We can figure that out almost instantly. So let me just draw through the magic of Zoom here. I'm just going to draw my vectors like that so that I can just grab them and move them around. All right, so let's draw a coordinate system over here. Okay, here's my coordinate system. Let me center it a bit more. Okay, so there's my coordinate system. Now, my instructions were to grab A and then draw A starting from the origin. So there's A, starting from the origin. Next, we do vector B starting from the end of vector A. So by that, I mean this. So we draw vector B starting from the end of vector A. So there's B. And vector C is going to be the one which goes straight from the origin to the end of B in one step, like that. So in this case, I can predict that vector C is almost in the positive y direction. It's going to have x component almost equal to 0, which is probably not something you could have really just seen from the from vector A and vector B, but I can just see it now by doing this geometry. By the way, as a side note, just like in algebra, addition is commutative, meaning, let me over here, let's do another problem. Let's do B plus A. Suppose we do B plus A. So we would do B first, B starting from the origin, and then A after B. And you see we actually get the same answer. So A plus B gives you the same result as B plus A. So if I draw vector C in here, so there's C, and we can even match them up at the end of the day. So there's my one vector C, here's my other vector C. Well, they're a little bit different because my drawing isn't perfect, but they should be identical to each other if you do it perfectly. So that's how you add vectors geometrically. A few notes about this. Another way to think about it is, let me move, get some stuff out of the way. Let's use this right-hand coordinate system over here. If you draw vector A starting from the origin, so this is A, and then we draw vector B starting from the origin. Whoops. Heck, okay, forget it. You know that's an A, and this is a B. Okay. If we draw them both starting from the origin, vector C is going to be in between vector A and vector B. Okay. So there's C. Well, it kind of faded to the background, but there's C. So you can see it's like in between A and B. And furthermore, we can even think of this as being a quadrilateral if we want, where we have AB and AB coming to A plus B and B plus A coming together like that to give you C as like the diagonal of the quadrilateral. So there's a number of different ways you can think about it here, but all of them give you the same result. So oftentimes it's a good idea when you're doing vector addition to kind of sketch it out this way and get a rough idea of what the sum is that you're looking for as like a little bit of a quick check of whether your answer that you do quantitatively is on the right track at all. And in some simple problems, you might even be able to just solve it this way. Or conceptual problems, you might just be able to solve it this way by saying, oh, clearly from the visual, from the geometry, I can see that the answer points in, you know, in this case, it's basically in the positive y direction. Done. I don't have to do any calculation. So it's a useful tool to have in your pocket. But in the next video, I'll show you how to actually crunch through this quantitatively and find the magnitude and direction of C.